Welcome guys. I'll show you how you can find the equation of a trigonometric graph. Now we will definitely need to remember the graph of y equals sine of x and all its properties, the turning points, the amplitude, the period, and so on. That is the same for the graph of cosine of x. We need to know the amplitude, the turning points, and all the other things, as well as the tangent graph. So that is really the starting point. Let's look at an example. We are given that graph there. Now, there are two approaches to this particular question. Somebody looking at that graph may see something very close to the graph of sine, and yet another person might think this could be a graph of cosine. So I can see two people here, one person approaching this from the sine point of view, and another person approaching the same question from the cosine point of view. There's no problem, you can start wherever you want. This is either a cosine graph or a sine graph anyway. And again, we know that sine and cosine are related. That is why we talk about cosine. So you will still get your correct answer whether you are treating that as a sine graph or you are treating that as a cosine graph. Let me show you both methods, and let us start with sine. Let's assume that this is the graph of sine. So if this is the graph of sine, then we expect the equation of the graph to look like this in general. So we expect the equation of the graph to look like that. And so we need to determine here the value of A, the value of B, the value of P, as well as the value of Q. Right, so let's go through this together. I want to try and draw that graph together with the graph of sine of x so that we can see the comparisons very quickly. That is where 45 degrees is. So that is the point 45, there. Our graph passes through that point 45. So it's something like this. Just draw a rough graph. Looks something like this. Okay, so it looks something like that. So this is how they compare if you draw them together. And clearly, these two are different from each other. And so the equation of the red graph cannot be the same as the equation of that black one there, although they are related. Now, this is the thinking process that I would have to go through. Looking at the graph of sine x and comparing it to the graph that is red, I notice the turning point for the graph of sine x, it is at 90 degrees 1. So there is a turning point there at 90 degrees 1. There are so many turning points, but I just need to pick one. So there's a turning point at 90 degrees 1 for the graph of sine x, and yet there is a turning point at 45 degrees and 0 for the required graph. So what this means is there should have been a transformation here which transformed the point 90 degrees and 1 to become 45 degrees and 0. All right. So these are the turning points. Now, if you compare the angles, the graph of sine has x equal to 90, but the required graph has x equal to 45. So what happened there? It would look like from 90 degrees up to 45 degrees, there should be a horizontal shift to the left. So the graph of sine x is shifted 45 degrees to the left. Now, shifting 45 degrees to the left tells us straight away that the value of P in that equation up there should be equal to 45. It's positive 45. So P is 45. We now know P. We are happy. Let's continue and see what's happening here. If you compare the two graphs again, the point 90 degrees and 1 compared to the point 45 degrees and 0, you'll notice that the turning point is like upside down. It looks like there is a reflection that took place here. And that straight away tells me what A is. So from 91, there should be a reflection along the x-axis. But if I reflect this along the x-axis, I will obviously go to 90 and -1. So I'll come here. That will be the point I get after reflecting 90 degrees 1 along the x-axis. Now, if you look at the amplitude of sine x, the amplitude of sine x is 1, but because there is a reflection, this actually tells us that A should be equal to -1. I need you to understand why there is a minus. The minus is telling us that we reflected along the x-axis. So that point 91 was reflected along the x-axis, and it obviously went to 90 degrees and -1. But then how did it go back up to sit at 45.0? That means there should be a vertical shift again. So after reflecting it along the x-axis, we need to shift this thing 1 unit up again. And that tells you straight away that Q is equal to 1. Remember, we're shifting sine x 45 degrees to the left. So you do this first, and then you reflect, and then you shift 1 unit up. So we get P, A, and Q. The only thing that is missing now is B. B will come with the period of the graph. Now look at the graph that we are trying to find. You will notice that point there is at -135. And the final point here is at 135. So if you look at that one clearly, it looks like that is only 3/4 of a complete cycle. But from -135 up to 135, that must be 270 degrees. So clearly, 3/4 of the period is 270 degrees. That is just 3/4. But we need 4/4, a complete cycle. So if 3/4 of the period is 270, then it means the period itself should be 360 degrees. Now, if the period is 360 degrees, you now need to remember that period is always found for sine. We take 360 degrees and divide it by the coefficient of x. So 360 over b should be equal to 360 degrees. And if we solve this for b, we will get a 1. So guys, we now know b as well. So b is equal to 1. And now that means we have the equation of this graph. I'll write it here. The equation should therefore be equal to y. Y should be equal to a, but a is -1, multiplied by the sine of bx, b is 1, plus p, but p is 45. degrees. All that plus q, which is plus 1. Simplify that. So our answer is y equals negative sine of x plus 45 plus 1. Right, that will be the required answer there. So this is for somebody who assumed sine right from the beginning. But what about somebody who thinks this is cosine? Let me show you what will happen if you think this is cosine. Once again, I'm just going to draw the required graph there. That point minus 45 is somewhere here. So we are looking for the equation of this graph. And we suspect this is a cosine graph. So if we think this is cosine, then the equation should be in the form y equals a multiplied by the cosine of bx plus p, all that plus q. Right, once again, this time I would look at the turning point for the graph of cosine of x. The turning point, I'll use this one. There are many others. You can use any one of them, but I prefer to use this one now. Now, you will notice there that that turning point there is at 0 degrees and 1. So now I'm comparing that turning point to this turning point. This one is 45 degrees and 0. So it looks like 0 and 1 is transformed onto 45 degrees and 0. Now look at the angles first of all. From 0 degrees to 45 degrees. Do you see that? From 0 degrees to 45 degrees. That speaks of a horizontal shift, and we are shifting to the right from 0 to 45 degrees. And if we are shifting to the right, that means the value of P should be negative 45 degrees. So in this case, if you are dealing with cosine, or if you are using cosine, then P will be equal to negative 45. Now look again at the y coordinate. The y value at the turning point is 1 for the graph of cosine, and the y value at the turning point for the required graph is 0. So from 1 to 0. And if you actually look at the diagrams that are drawn here and look at the turning point, it looks like these turning points are reflected or are reflections of each other along some line. So in this case, we are reflecting first of all along the x-axis, which means again that a must be equal to negative 1 because we are reflecting along the x-axis. But clearly, if you reflect 0, 1 along the x-axis, you will get a point, or you will get to the point 0, negative 1. Then obviously you shift it 45 degrees to the right. You shift it 45 degrees to the right. That is what we said up there. Now, do you see that you will then again need to shift it vertically for it to end up at 45, 0? You now need to shift it vertically by 1 unit. So that tells you that Q is equal to 1. We're now missing B. Right, and B is always going to be found from the period. We said earlier on when we were dealing with sine that the period of this required graph is 360. It hasn't changed. It is the same thing. So the period is 360, and that tells us that B is equal to 1. If the period is 360, then B will be equal to 1. And so that will give us the equation that we are looking for. I'll write it here. So the equation should be y is equal to a, but a is negative 1. I'll just write a minus. Cosine of bx, but b is 1, so I'll leave 1 and just write x, plus p, but p is negative 45. So this is negative 45 degrees. All that plus q, which is equal to 1.